Hello everyone. Today, I, Angita Girindran, Anand Jacob, and Brunel John are here to present on the topic Box-Cox Transformation. Box-Cox Transformation was introduced by statisticians George Box and David Cox. The reason why they collaborated on this paper was just because of their similarity in their names. Now, many statistical methods assume the normality of data, but data is not often normally distributed and it can be skewed or exhibit other non normal characteristics. This is where we use Box-Cox transformation. Now, what does it have to do with multiple regression analysis? See, when the relationship between the dependent and the independent variable is not linear, but still we wish to fit a linear model, then we consider a Box-Cox transformation model. Now, nextly, the benefits of Box-Cox transformation include less skewness, maintaining the linear relationship between response variable and predictor variable, almost equal spread, etc.
The mathematical formulation of Box-Cox transformation is as represented, where y is the original data and y lambda is the transformed data. The lambda parameter controls the degree of transformation applied to the data. If lambda is not equal to 0, the data is raised to the power of lambda and then shifted by 1. If lambda is equal to 0, the data is transformed by taking the natural logarithm. Some of the common Box-Cox transformations are as follows. The two main types of transformations are a power transformation involves raising the data to a certain power. Logarithmic transformation involves taking the logarithm of the data. This can help to normalize skewed data. The Box-Cox transformation involves finding the optimal value of lambda, which is the power parameter that maximizes the log likelihood function. The log likelihood function measures how well the transformed data fits a normal distribution.
Now we will see to find the optimal value of lambda, the following steps can be followed. The optimal value of lambda, it is the one that maximizes the likelihood function and it lies between -5 to 5. Try different values of lambda until the transformed data is normal. Here we will see the applications that applies in real life data. Here is an example of how the Box-Cox transformation can be applied to real data. Suppose we have a data set of house price and we want to build a linear regression model to predict the price of a house based on its size and location. However, we plot the data might be highly skewed. To apply the Box-Cox transformation to this dataset, first identify the response variable, which is the housing price. Then we apply the Box-Cox transformation to the response variable using a range of lambda value. We select the lambda value that maximizes the log likelihood function. After applying the Box-Cox transformation, we plot the transform data and check if it follows a normal distribution. If the transform data is approximately normal, we can build a linear regression model using the transform data as the response variable. Here we come to the conclusion. The conclusion, it concludes Box-Cox transformation is a essential tool for normalizing non-normal data and eliminating skewness and improving the accuracy and reliability of the analysis. Overall, it will be useful for researchers who need to work with non-normal data.